Hi, hello everyone. This is your educator, your tutor, your friend, Sanjay Kumar Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button and share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. You can also visit our website www.we-learning.in. All the live classes what we are providing, you will be getting all the classes there. Along with that, you will be getting lecture notes of each and every class. Okay, go download it. It will help you to study. All right. Now, without any delay, let's get started with today's session. We are going to start a new chapter today. I hope you all are ready with new energy. The chapter is current electricity. Very easy chapter, right? Very scoring also from board's point of view. Why? Because you are already studying this chapter from your 10th standard, right? Same concept, similar theories, similar questions. Only a bit in detail you will be studying in this. Okay. So in this lecture, you are going to study electric current. Then we'll be seeing drift velocity and then mobility of electron in a conductor. All right. Now, let's see electric current. You already know. We'll do a small recap of it. Okay. What is electric current? We already saw in 10th standard, current means flow, right? Air current you would have heard, water current you would have heard. When air flows, we say air current. When water flows, we say water current. Electric current means when charges flow, we say electric current. All right. The rate of flow of charge is what electric current is. Electric current is the rate of flow of charge. Suppose this is a conductor. Here, if we provide potential difference, the charge will start moving. Let's suppose this is the cross-section area. From this cross-section area, if I just want to know how many electrons are passing in how much time, number of electrons passing in a unit time is current. Clear? So from here, number of electrons means the amount of charge passing this per unit time is current. Okay. I average is equal to delta Q by delta T, amount of charge flowing from that cross section per unit time, charge flown upon time taken. Okay. Now this is average current. If I want to ask instantaneous current, instantaneous means at this very instant, how many electrons, how much charge passed. On an average, let's say in 2 minutes, how much charge passed we can tell. In 1 minute, how much charge passed we can tell. In this particular instant, how much charge passed, that is instantaneous current. Okay. So instantaneous current is dq by dt. In a particular instance, very small amount of charge, that is dq. In a very small amount of time, that is dt, if it is passing, rate of flow is dq by dt, that is instantaneous current. This is average current, this is instantaneous current. Remember this. All right. Okay. Now, SI unit of current is Coulomb per second. Coulomb per second means ampere. Coulomb per second means ampere. We already know this. If you remember, this ampere is a fundamental unit. Remember, there were 7 fundamental units in your 11th standard you would have studied, right? There were 7 fundamental units. In those 7, one was ampere. That is why it is important. Fundamental unit, I'll write. Okay. It is one of those 7 fundamental units. Coulomb was not fundamental unit, right? Ampere was a fundamental unit. Okay. Now, current is scalar or vector? What do you think? Vector quantity is something which is having direction and magnitude both. Current, it has direction also. It has magnitude also. Right? Current has direction. We mark it with arrow, like current is flowing in this direction or current is flowing in this direction. Current has direction also. Current has magnitude also. Current has direction. Current has magnitude. But in your 10th standard, you studied that current is a scalar quantity, right? Why? Because in spite of having direction, it does not follow vector law of addition, right? It does not follow vector law of addition, but it's not a vector quantity. because it doesn't follow vector law of addition. Vector law of addition means triangle law, parallelogram law. Clear? So it is not a vector quantity. So then what is it? According to CBSE, it is a scalar quantity. All right. But now, see, if you see current, it is going in this direction, let's say 2 ampere. Here it is going 3 ampere, let's say. How much will be coming out from here? 5 ampere. So it is not following vector law. Let's say this will be in some angle, 30 degrees, 60 degrees, 45 degrees. But it does not matter in whichever angle it is. It does not follow vector law of addition. It will be directly added. 2 plus 3 is 5. As simple as that, right? So since scalar addition, scalar means normal addition. Whatever angle doesn't matter. Whatever position doesn't matter. All right, just we'll add it up. Correct? Since it is following scalar addition, it's a scalar quantity. Scalar quantity. If you want, you can write down. Now, see, it is a scalar quantity according to our syllabus. According to our syllabus, it is scalar quantity. All right. But in some books, you will find that it is a tensor quantity. In some books, they will write it's a tensor quantity. It's a tensor quantity. Correct? What is a tensor quantity? It is a different kind of quantity which is neither a vector nor a scalar. If you see this current, it is not completely vector. It has direction, it has magnitude, but does not follow vector law of addition. It is neither completely scalar, because scalar is something which only has magnitude, like mass. Right? 2 kg, 3 kg, 5 kg, only magnitude, but this has direction. So it is neither completely vector nor completely scalar. That's the reason it is a tensor quantity. So if in exam, let's say it comes and in the options, if tensor is written, tick that. Okay? If tensor is written, tick that. If tensor is not written and scalar is written, then tick scalar. If tensor, scalar, vector, all three are written, you have to tick on tensor. If tensor is not written, then the priority is scalar. Clear? It's a scalar quantity. Okay. Next. According to your boards, it's a scalar quantity. Remember, scalar quantity. Forget that. Forget that. Next. Direction of electric current. What is the direction of electric current? What we studied is opposite to the flow of electrons, right? Or in the direction of flow of positive charge. Positive charge does not move, but in the opposite direction of electrons, we assume that the positrons are moving, right? The positive charge is moving. So in that direction, we consider the direction of electric current, or from higher potential to lower potential. There are three conditions or three ways you can understand the direction of electric current. First, high potential to low potential. If you are saying this is high, this is low, you can easily understand, okay, this will be the direction of current. Second, how you can see is by seeing the direction of motion of positive charge. Third, how you can see is if you are not able to see these two, just see in whichever direction the electron is moving, opposite to the direction of motion of electron will be the direction of current. Okay, very basic. So now, current carriers. Current carriers, we know there are three states of matter: solid, liquid and gas. Okay, in all the three, some current carriers will be there. If I talk about solids, we know conductors, right? We know insulators, right? We know semiconductors, right? Conductors, insulators, semiconductors. There are three kinds of solids. In conductors, current is in the form of free electrons, right? Free electrons are there. The charge carriers, the current carriers are free electrons. In insulators, no current carriers, no charge carriers. Okay. In semiconductors, again free electrons are there. Free electrons, holes. Okay. Liquid. Liquid, positive and negative ions. Normally in water, if you see, there will be no current carrier. But let's say if I mix salt in that water, so now the Na plus and Cl minus will be the charge carriers. Okay, they will be the current carriers. It will start conducting. Okay, so positive and negative ions will be the charge carriers in liquids. If I talk about gases, the charge carrier in gases, normally in gases no charge carrier is there, but if very high potential difference we apply, then at very high voltage, positive and free electrons will be the charge carriers. All right, positive ions and free electrons will be the charge carriers. Got it? Usually we will be seeing conductors. Okay, next, let's see a question. Q is given to be 2t square plus 3t plus 2. Q as a function of time they have given. We have to find current at t is equal to 4 seconds, and we have to find average current from 0 to 3 seconds. Current at t is equal to 4 means instantaneous current. At this instant I need current. At this instant, if I want to find current, what do I have to do? I instantaneous, if you remember, I instantaneous is dq by dt. Are yes or no? I have to differentiate this with respect to time. That means with respect to t. So if I differentiate this, this will be 4t plus 3. Correct? 2 2s are 4, t plus 3. So now at t is equal to 4. Here at t is equal to 4, this will be equal to 4 into 4 plus 3, that is 19 amperes. 19 amperes. All right. Okay. Second is average current from 0 to 3 seconds. Average current means delta Q by delta T. I average is equal to Q2 minus Q1 upon T2 minus T1. Q2 means charge at 3 seconds when I put T is equal to 3, and Q1 means when I put T as 0. T2 means 3, T1 is 0, right? So if I put Q2 will be, if I put T as 3, 3 3s are 9, 2s are 18, okay, 2 into 3 square plus 3 into 3 plus 2 minus 0. Here, if I put, sorry, not 0, it will be 2. Okay, I need some space. This will be 2 into 3 square plus 3 into 3 plus 2 minus 2. Correct? Minus 2, why? If I put T as 0, it will be 0. If I put T as 0, it will be 0. Only 2 will be there. So Q1 is 2. Q2 is this. T2 will be 3. T1 is 0. That is 3 3s are 9, 2s are 18 plus 3 3s are 9. And this 2 and minus 2 will be cancelled. Correct? 27 divided by 3, that is 9 ampere. This is instantaneous current, that is average current. So if Q as a function of T is given, can you find out the current? Okay. Now suppose I is given to you. Current is given to you, again as a function of time. Now you have to find the charge flown in 4 seconds and number of electrons flown in 4 seconds. How will we do that? Again, I is equal to dq by dt. So now I is equal to dq by dt, that is equal to 3t square by 3t square plus 2. So dq will be 3t square plus 2 dt. Charge flown in 4 seconds. In 4 seconds, if I want to find, I'll integrate it from 0 to q. This will be 0 to 4 seconds. So if I integrate this, this will be 3 will be constant, t cube by 3. 3 and 3 will be cancelled. This will be t cube plus 2t. See, t square is t cube by 3. 3 and 3 will be cancelled because it is in denominator. Here 2t, and integration is from, limit is from 0 to 4. That is 4, if I put 4 cube plus 2 into 4 minus 0 cube plus 0, that is 0 only. So that is equal to, Q is equal to 4 4s are 16, 4s are 64 plus 4 2s are 8, 64 plus 8 is 72 Coulomb. Clear? Everything is in SI unit we are considering. This will be 72 Coulomb. Now, second is number of electrons. How will we find number of electrons? This charge is what? Charge is equal to number of electrons into charge in one electron. If 2 electrons are there, if 2 electrons are there, how much is the charge in 2 electrons? 2 into charge in 1 electron, 2e. 5 electrons are there, how much is the total charge? 5e. 10 electrons are there, how much is the total charge? 10e. 10 into 1.6 into 10 power minus 19 Coulomb, correct? So Q charge is there, or let's say n electrons are there, so how much will be the charge? Q is equal to Ne. Q is given to be 72. That is equal to n into 1.6 into 10 power minus 19. Now here, if I remove this 0 will come here, or let me write another way. This will be n is equal to 72 divided by 1.6 into 10 power minus 19. If I remove this, a 0 will come here. This will be 4 4s are 16, 4 1s are 4, 32, 4 8s are 32, 180, again 4 4s are 16, 4 5s are 20, 45 into 10 power 19. N is equal to 45 into 10 power 19. Clear? These many number of electrons. Easy question. Okay. Let's see the next one. Drift velocity. Very important. They'll ask the derivation of drift velocity in exams, in boards usually. Okay, then they will ask, sometimes they ask the relation between current and drift velocity. Again, it's a board's question. Very important from board's point of view. Okay, to understand this, I'll tell story, the classical story of current. Okay, let's understand. See, in electrostatics, what we have seen, suppose there is a conductor. Now, if this conductor is kept in an external electric field, this is an external electric field. If this conductor is kept in an external electric field, E net inside is 0, correct? E net inside in any conductor is 0. In electrostatics, we have studied this. This is because this conductor is isolated. Okay? E net inside any isolated conductor kept in an external electric field will be 0. Why it is 0? Very simple. There are a lot of free electrons inside this, a lot of charge inside this. The moment there is an external electric field, the negative charge will start moving. Suppose there is a lot of negative charge, the negative charge will start moving towards opposite of electric field. So all the negative charge will come here. All the negative charge will come here. Since negative charge has come here, the positive charge will come here. Actually, positive charge doesn't move. Electrons are moving, right? Negative charge is moving. We assume that if electrons have reached here, protons will be, positive charge will be this side, positrons, correct? So now there will be an induced electric field from positive to negative. This E induced is equal to E external. If I talk about the magnitude in vectors, if you are talking this E induced, electric field induced inside this is equal to minus E external. Okay, that is the reason inside this. That is the reason inside this E net is equal to 0. Because E net will be, all this E external is like this, right? E external is in this direction. E induced is in opposite direction. So inside this, there are two electric fields. One is in this direction, one is in this direction, and both are equal. They will cancel each other. The net electric field inside any conductor is 0. Clear? So every time the induced electric field will be in such a way that it is equal and opposite to external electric field. Okay, see, conductor is having a lot of charge. There's an ocean of charge. Okay, if this electric field is small, let's say less, okay, then less charge will come accumulate at the end. Less charge means this electric field will also be small, right? So this will be according to this. This will always be there. Okay, if it is an isolated conductor, this will always be true. This, okay, so if less electric field, that means less charge will come here, so less EI will be there. This will be equal and opposite to this. If this is very strong, a lot of charge will accumulate at the ends. This EI will be more now, greater now. This will be equal and opposite to this every time. Okay, so this we have seen in electrostatics. This charge at the end is static. It is not moving. Okay, now suppose when there was no electric field, in the absence of external electric field, the electrons which are inside this, free electrons, will they move or not? Right now, let's say they move that side, they move that side. Still, there are a lot of charge inside this. There are a lot of free electrons inside this. Are they moving or not? Or they are just stabilized? Tell me. Are they fixed at some position or they are moving? They will be moving, right? They will be doing random motion. Whether external electric field is there or not there, I am just talking that before this external electric field, what is the situation? All the electrons are doing random motion inside it. Some electron is moving in this direction, some electron is moving in this direction, some 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 is moving in this direction. Random motion is happening inside it. Right now also, some charge has come according to this particular relation, right? This EI should be equal to this. According to this, the charge has come at the end, but still there is a lot of free electrons which is there inside, which is doing random motion. Why they are in motion? Thermal energy, right? This we have already studied a lot of times. Whenever there is a temperature difference between the environment and the conductor, suppose this conductor is at 25 degrees Celsius, this surrounding is at 28 degrees Celsius. Now this is 3 degrees more, right? Heat transfer will happen from here to here. Since heat transfer will happen, these electrons will get kinetic energy. Since this thermal energy, because of this thermal energy, they will get kinetic energy. They will start moving. Random motion will start happening. Here and there, they are moving. Okay, I hope you understood this. This is happening due to thermal energy. All right, but whenever you touch any iron rod, let's say, do you get current? No, right? If suppose that is an isolated iron rod, that means it is not connected to any battery. No wire is connected from both the ends, or nothing is there. Just an iron rod. If you touch it, do you get an electric current or electric shock? No, right? But we know that if the electrons will be moving, there will be current. So if these electrons are doing random motion, if these electrons are moving, why there is no current in any conductor, any isolated conductor? The reason is, they are moving in such a way that average velocity, U average, is 0. Clear? See their direction, it is very random. If this is moving in this direction, this is moving in opposite direction. Right? This is moving in this direction, someone is moving in opposite direction. If you take U average of all the electrons, it will be 0. This U average means vector sum I am talking about. Let's say this is having thermal velocity U1, U2, U3, U4, U5, U6. Okay, let's say this is the situation. Here electrons will do random motion. This order of this velocity is around 10 power 4 meter per second. 10 power 4 to 10 power 5 meter per second. This is the order of this velocity. Very high speed they are moving. Zug, 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 zug. Like this they are moving inside that conductor. All right. So now if U average will be U1 plus U2 plus like this till UN divided by N, correct? This is vector. This U average is 0. This U average is 0. Okay? Because of which there is no electric shock or electric current inside that. Understood? Now see. Remember this. U average is 0. U1 plus U2 plus UN vector is 0. Acha, if I ask you that average speed, will it be 0 or not? No. Average speed is not 0. Average speed is total distance upon total time, right? Total distance, if you see, they are traveling a lot of distance. If they are doing a lot of distance, they are traveling, right? Average velocity is 0 because it is actually involving the direction also. If they are moving in this direction, if they come back, average velocity is 0, but speed is not 0. Okay. Acha. Now if I ask you for only one electron, will the average velocity be 0? This I told for all the electrons, right? U1, U2, C for first electron, second electron, like this, n electrons. Average velocity will be 0. If I ask you for only one electron, will the average velocity be 0 or not? It will be 0. Okay. If you see for all the electrons also, like this, the average velocity will be 0. If you see for this particular electron also, this single electron is only doing zug, 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 right? If it goes like this, it will come back. If it goes like this, it will come back. Like this, on an average, the velocity is 0. Clear? For single electron also, average velocity is 0. For all the electrons also, average velocity is 0. But average speed is not 0. It is very high. Okay. All right. Now see, this is a conductor. This time now we are going to study electric current. It is not electrostatics. The electric field inside will not be 0. Suppose if I connect it with a battery, what will this battery do? Battery supplies electrons. Is it true? No. Battery does not supply electrons. Battery moves the electrons. This battery will move the electron inside this conductor. This battery will provide potential difference. Because of this potential difference, there will be an electric field. Let's say this electric field is E external. Okay. Now this external electric field, in this conductor there is an electric field. Inside the electric field is not 0. Net electric field is equal to E external. E net inside is equal to E external. There is only one electric field. Why? Let's see. I told you there that the electrons will be accumulating here opposite to this E external. Proton or positrons, the plus charge will be accumulating here. But the moment we connect it with the battery, now it is not isolated. A wire is connected. These electrons have now a path to go. They have a road in front of them to go. Right? Earlier there was nothing. Right now they start moving from here. They will start moving from here. Because of which, see, the electric field which was induced inside was due to this positive accumulation, due to this negative accumulation. Correct? Here if you see, charge is accumulated. Charge is accumulated. Correct? But here the charge now which was accumulated is no more accumulated. Charge is no more accumulated. Why it is not accumulated? Because now it will start moving. Since it will start moving, this accumulation will reduce, and ultimately this accumulation will become 0. This charge will start moving like this. If the charge is kept here, positive charge, here negative charge, then there will be electric field from this to this, right, in this direction. But if there is no charge only, accumulation is only not there. It is moving constantly, right? Because of which E induced inside will become 0 slowly. There is no, slowly means within microseconds. The moment you connect the battery, first of all, there was no external electric field. When we connected the battery, there was external electric field. correct? Here I have shown you the case where external electric field will be there. In that, if I put a conductor, what happens? I was just reminding you of the electrostatics. Now here, there is a conductor. The moment I connect a battery, there is an external electric field. The electric field will start flowing, right? But there is only one electric field. There is no induced electric field here because there is no accumulation of charge. The moment you connect the battery, charge starts flowing. There is no accumulation. Okay, so there is only one electric field like this. There is nothing which is opposing it. So E inside is not zero. E inside is this E. Let's say it is only E. I am not making it as E external. Inside this there is an electric field now. Inside a conductor there is an electric field now. So now the electrons which are there inside, there are a lot doing random motion. Zoom, 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 zoom like this, right? There is electric field inside now. This electric field, if there is an electric field, right, and charge is present in an electric field, what will happen? This charge will experience force. This charge will experience a force. Since it is an electron I am talking about, it will experience force opposite to that of electric field, right? Q into E. E into E. E into E. Right? So now, if force is equal to, if I write in vector form, it is minus E into E. Minus I am not putting because of negative charge, because of the direction. Force is in this direction, electric field is in this direction. I am writing vector. Okay? So that means acceleration will be there with the charge. Acceleration will be E into E divided by M. Correct? If this charge is having this, M is mass of electron. This M is mass of electron. Acceleration will be minus E vector by E, M. So now that means this charge is moving with acceleration. I told that electricity in the very first chapter, in the very first lecture, when I told we'll be studying electrodynamics in 12th standard, first we'll be studying charge at rest, that is electrostatics, then charge in motion where charge will be moving with constant velocity, that is electricity. Then we'll be seeing accelerated charge, that will be electromagnetism, electromagnetic waves and all those things, correct? But here we are studying electricity and the charge is moving with acceleration. How is this possible? Contradiction, right? Actually, overall if you see, this charge is not moving with acceleration, it is moving with a constant velocity. Let me explain you. No doubt, individually if you see, this charge is moving with acceleration. It is having acceleration. Velocity will increase. With an increasing velocity it is moving, no doubt in that. Alright, but try to understand. Here only I'll explain. When this electron is moving, the path is not free. The path is not free. There are other electrons also. There are atoms also. When this will move, it will do a lot of collisions with them. It will not go peacefully, it will not go. It will do a lot of collisions here, there, and then it will move. What will happen in the books it is written? It will collide with the kernels. What is kernel? When an atom, it loses an electron. Suppose this is an atom. It has lost an electron, it will become positive. So now this is a kernel. Like this, there will be a lot of kernels there because there are a lot of free electrons. The free electrons have come out from this atoms. So this electron, when it will move, when it is moving in this direction, since this is positive, this is negative, it will try to attract. Correct? It will try to attract. So like this, it will go there, collide. Again, it will come. Force is constantly acting. Here in this situation, let's say electric field is in this direction because I am showing the motion of electron in this direction. Okay. So now, due to this electric field, this electron is having acceleration. It is moving with an increasing velocity. It is moving, but because of this kernel, this will collide. Again, it will come here. Again, there are other kernels. Let's say there is other kernel here. There is other kernel here. A lot are there. A lot are there. So now this went, speed increased. Again, speed decreased. Velocity decreased. Correct? Again, it came here. Again, it was increasing because of this electric field. Again, velocity decreased. Let's say it came here, then here. So many collisions, this electric field is increasing the velocity. This acceleration is increasing the velocity. Because of this collision, the velocity is decreasing. Again, the acceleration will increase the velocity. Because of this collision, the velocity will decrease. So velocity is increasing and decreasing. Increasing due to this electric field and decreasing due to the collisions. So this increasing, decreasing, increasing, decreasing, on an average, if you see, overall if you see, you will see this electron is moving with a constant speed, constant velocity. Okay, how? See, velocity is displacement upon time. If this is the conductor, let's say, electric field is in this direction, I'm showing electron movement in this direction. Okay, I want to see in how much time this charge is passing this conductor. That's how I will write the current. Correct? But the charge is actually not moving in this direction. The charge is doing random motion still. It is having thermal energy also. It is having energy due to this electric field also. Correct? So now this electron is moving like this. Let's say this is doing a random motion. Okay. Now suppose if it was doing zigzag, for explaining you I'm telling, let's say if it is doing zigzag. In this direction, it has covered only this distance. If you consider the total distance, it is till here. From here, zigzag motion, if you consider total distance, it is a lot what it has covered. So the speed is no doubt high, but velocity is displacement upon time. If you see in this direction, it has only shifted a bit. Maybe due to high acceleration, it has covered a lot of distance. But if you see in this direction, it has only shifted a bit. It came here. Overall, if you see, it is seen that this electron practically it is moving with a constant slow velocity. Very slow constant velocity, and that velocity is drift velocity. Alright, this is not only one electron what I am talking about. I am talking about all the electrons inside this conductor. They are doing zigzag, 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 zumba, 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 like this they are doing the motion. Okay, in every direction they are doing. Fine, but overall, opposite to the electric field, they will move only a bit. They will just drift. They are just drifting. I want to see in this direction how they are moving. They are just drifting. They'll do like this, like this, like this, like this, and drift a bit. So if I see this displacement per unit time, it is coming as constant, that is drift velocity. Okay, drift velocity is average velocity of all the electrons. I hope it is clear. All right. If you want, you can write it down. It seems that the electron will move with acceleration, but in reality, electrons, just because of collision, are moving with a constant velocity, that is drift velocity. Okay. Now, let us see the formula for drift velocity. How do we get the formula? Understand? Let's see, this is an electron. This is one kernel, this is another kernel. First, let's say electron went there, here, then it went here. The distance between two collisions, the distance here, two collision happened, one here, one here. The distance between two collisions is known as lambda. Okay, and the time taken between two collisions is known as tau. This tau is nothing but relaxation time. Relaxation. Okay, this lambda is free path. See, this much path was free, that's why they have named it as free path. Okay, so the distance between two collisions is lambda, the time taken between two collisions is tau, that is relaxation time. Clear? It is getting only so much time to relax. Then again one collision happened. Then it is relaxing, again one collision happened. Like this. There are crores of electrons. See, just imagine how much collision is happening. Because of so much collision, the acceleration should be there, but they are moving slowly, 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 colliding, 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 slowly they are moving. Okay, the order of this velocity is around 10 power minus 4 meter per second. This much slowly they are moving. 10 power minus 4 meter per second. So slow. Okay, So now, this I hope you have written. Let's say there are a lot of electrons, n number of electrons. One electron is this. For him, this tau is tau 1. Initially, it was u1. This is thermal velocity due to thermal energy. Then, due to electric field, it started moving, collision started happening. Then, here, let's say it reached v1. This is first electron. Another electron like this. A lot of electrons are there. Let's say n number of electrons are there. For another electron, this, it went here, then it went here. Let's say this is tau 2. This is u2. This is v2. Correct? Lambda 2, the distance. Here the distance, let's say lambda 1. Like this, n number of electrons are there. Okay. So now if I want to write this v1, drift velocity, first of all, drift velocity is nothing but v average of all the electrons. Average velocity of all the electrons. That is, okay, there is less space. I'll just write Vd. Average velocity, that means V1 plus V2 plus so on till Vn divided by n. Okay. Now what is V1? Can you tell me what is V1? For this, V is equal to U plus AT? Yes or no? That is U1 plus acceleration A that we have already taken out, T is tau 1. V2 will be U2 plus A tau 2, correct? Vn will be Un plus A tau n. So this will be, now if you see U1 plus U2 plus U3 plus U4, let me write here only. Let me write here only. V1 is equal to U1 plus A tau 1. V2 is equal to U2 plus A tau 2. V3 is equal to U3 plus A tau 3. Like this. V3 I am not writing, space is less. Vn is equal to Un plus A tau n. If I add this, V1 plus V2 plus and so on till Vn, this will be U1 plus U2 plus so on till Un plus A is common, tau 1 plus tau 2 till tau n. A common, tau 1 plus tau 2 till tau n. Correct? Why A is common? We have already taken out. A is E by M minus E vector by M, right? Just now. So this is the sum of all the velocities. Average means if I divide by n both the sides. So this will be Vd is equal to V1 plus V2 plus V3 plus, forget about V3, and so on till Vn, divide by n plus, total I am dividing, U1 plus U2 till Un plus A common, tau 1 plus tau 2 plus and so on till tau n. Correct? Total divided by n. If I separate this divided by n, this divided by n. Now see here, this, what is this? Okay, just a second. From here what we got is V1 plus V2 till Vn is equal to, this is equal to U1 plus U2 till, okay, let me write again. See here, from this we got V1 plus V2 till Vn is equal to U1 plus U2 till Un plus A common, tau 1 plus tau 2 plus till tau n. If I divide both the sides by n, this will be something like this. This is what? Vd. That is equal to, what is this? 0. Remember, U average, U1 plus U2 till Un divided by n, U average, that is 0. plus, that is A, this tau 1 plus tau 2 till tau n divide by n, tau average relaxation time, okay, average relaxation time. This is Vd. Vd is equal to A tau average. What is A? What is A? E by m tau average. If you want to write in a vector form, you can put a minus sign here. Vd vector is equal to minus E vector divided by m tau average. Okay, sometimes somewhere it is only written tau, that means tau average only. Okay, minus E vector by m tau, that is drift velocity. Did you understand the derivation? Very simple. Okay, in exams start the derivation from here. Mark this relaxation time, free path. So for this mark this also u1, initial velocity or thermal velocity, anything you can write. Then due to acceleration A, there is final velocity. U and V I am writing. 1, 2 means for that particular electron it is. U, V, this is final velocity. Okay, so then from this we can write this V is equal to U plus AT, V1 is equal to U1 plus A tau 1. Drift velocity is the average of all the velocities, V1 plus V2 till Vn divided by n. So from here V1 I have written for all the electrons from first electron till nth electron and I added them. So this addition is equal to this addition. From here dividing both the sides by n, this is Vd, that is 0 U average, and that is A into tau average. From here A is E by m tau average. Okay. Next, in terms of potential difference, so let's see if this is a conductor. If this is a conductor, see we are talking about electricity. You will always see potential difference. V is always there, battery is connected, potential is V, something like this you will always see, right? Because of this V, there is electric field like this. Let's say the length of this conductor is L, okay, electric field is E. V is equal to minus E dot dr or dx, correct? Delta V, this is dV, delta V is equal to, or V is equal to, this V is delta V only, right? Potential difference only across the terminals. So V is equal to E into L, correct? E is equal to V by L. E is equal to V by L. Now, understand here, we are only talking about scalar because potential is a scalar quantity. We know that Vd is equal to E by m into tau. Tau means tau average. Why I am not writing vector and minus sign? Because now I am going to replace this E by this scalar. Okay, so this will be EV by, in place of E I have written V by L, rest everything is same, tau average. That is drift velocity in terms of potential. Okay, drift velocity in terms of potential. Anyways, we know that the direction of this velocity will be opposite to electric field. Then this is potential, this V is potential, this V is drift velocity, where I have made it like this. Now, let's go further. Relation between drift velocity and current, very important from both point of view. Very important. Understand. Suppose there is a conductor. Before that, let's say there is a conductor. In this conductor, electron per unit volume. Let n be the electron per unit volume. Let n be number of electrons per unit volume. Acha, this is number of free electrons. Number of free electrons. This is a conductor. It is an ocean of free electrons. There will be a lot of free electrons. What we have considered is n is number of electrons per unit volume. So in 1 unit volume, these many electrons will be there. So this is basically, n is basically electron density. N is basically electron density. A lot of electrons are there in a unit volume. In a unit volume means 1 meter cube. 1 unit, 1 length, 1 height, 1 breadth, 1 meter cube. On and around 10 power 29 of that order free electrons are there. Fine, a lot of free electrons are there. So now we have to find the relation between drift velocity and current. Before that, let us just write I is equal to dq by dt. This is all connected to the battery and all, okay? Now, since we are doing electricity, nothing is isolated. It is all connected. There is external electric field, the electrons are moving, everything is happening. Whatever story we have studied, everything is happening, okay? Electrons are moving inside it. Let's say electric field is in this direction, okay? So electrons will be moving in this direction. Let's take a cross section. This is the cross section, let's say. From this cross section, how many electrons are passing per unit time is the current, right? Let's say in dt time, some electrons were there initially here at this cross section. In dt time, these electrons crossed this cross section, okay? But do you think only these electrons are there inside? No, right? There are a lot of electrons behind this. In front of them also, they are moving like this. So in dt time, let's say these electrons reach here. So if these electrons reach here, the electrons which were behind them, they will fill this space, they will reach here. Correct? So in dt time, how many electrons passed this cross section? How much electrons are present in this entire volume? How much electrons are present in this entire volume are the electrons which cross this cross section in dt time? Are yes or no? Correct? So now current is charge per unit time, dq by dt. In dt time, how much dq charge has passed, that is what current is. So now if I get to know the dq which is inside this, the charge which is inside this, I will get the current. So basically I need to find dq now. Okay. Charge is number of electrons into E. What is charge? Number of electrons into charge in 1 electron, simple. So now I need to find number of electrons. N I need to find. N is equal to number of electrons. Number of electrons. We know that this will always be given, that is electron density, number of electrons per unit volume. Number of electrons, N is equal to number of electrons per unit volume. If I need this is N into V. Are yes or no? So N is basically electron density into volume. What is the volume? Volume means in dt time, in this volume, how many electrons are there, correct? So this volume will be how much? This volume will be how much? Number of electrons crossing the cross section. In dt time. This is what this N is, okay? So now, how we'll find this? We will know the area of the conductor, the cross section area we will know. Let's say this cross section area is A. So this side, this cross section area will be A. A into this length. This A into this length is the volume. What is this length? Just now we found out that these electrons are moving with a velocity Vd, right? So if electrons are moving with velocity Vd and for dt time if they have moved, so how much distance is this? Vd into dt. Distance is equal to speed into time, correct? So this length will be Vd into dt. Where should I write? Okay, so N will be V is equal to area of cross section into L. L is Vd into dt. So this will be Na Vd into dt. This is number of electrons passing through this cross section. Now, number of electrons passing through this cross section is N into A into Vd into T. Right? How much charge? If these many number of electrons are there, charge is N into E. Number of electrons into charge in one electron, that is Na Vd into T into E. This T is dt. This is dq. This is dq. Now see, if I take this dt here, this will be dq by dt. That is N E A V D. N E A V D. This dt I have taken here. What is this? This is current. I is equal to N E A V D. रात की 2 बजे भी ये फॉर्मूला याद होना चाहिए. Very important. I is equal to NA VD. Very important. Okay. I hope you understood how we derived it. From here, if electron is moving with Vd velocity in dt time, from this cross section, how much charge how many electrons have passed? So the number of electrons into charge in one electron will be the charge which has crossed this cross section in dt time. That is what current is, dq by dt. So if you first write this, it will be easy for you to get the answer. This will be given to you in electron density. Okay. Next. From here, see, I is equal to NeAVD. If I open this Vd, we know the formula of Vd. E into E by M into tau. Tau means tau average, correct? E is V by N. NeAE V by L M into tau. Now see here, this is Ne square A tau by ml into V. Correct? If I want to write V from here, V is equal to ml by Ne square A tau into I. Correct? See here. I hope everything is correct. NEA VD is EE by M into tau. So this is Ne square A tau V upon ml. V will be ml upon Ne square A tau by I. A tau into I. Correct? See this formula. See this formula. M. What is M? Mass of electron. What is L? Length of conductor. What is N? Before N, let me tell you what is A. Area of cross section. Correct? Then E. Charge of one electron. Correct? Then N. Electron density. Electron density. Right? Tau. Relaxation time. Average relaxation time. Now understand, mass of electron is constant, length of conductor, if we choose a conductor, length of conductor will be constant, area of cross section will be constant, charge on one electron is constant. These two are also constant if temperature is constant. They both only depend on temperature. If we keep temperature constant, these two will be constant. depends on temperature. All right, rest write down all these constant. See here inside this, if I keep temperature constant, everything is constant. V is proportional to I. V is proportional to I. Ohm's law. Ohm's law. You have studied Ohm's law in 10th standard, right? This is how it is. V is proportional to I. Ohm's law says V is directly proportional to I, or I is directly proportional to V, keeping all the physical conditions constant, keeping the temperature constant. Correct? This is how it came. Ohm's law, we can say, keeping temperature constant. I can write V is proportional to I, that is Ohm's law. From here, we'll continue the next lecture where we'll be talking about Ohm's law. Okay, wait, it is not over yet. Okay, got it? Now, let's see mobility. The last topic, very small, 1 minute it will take. What is mobility? From the name only you can understand mobility means how much mobile something is, how much freely it can move, right? In a conductor, how much freely an electron can move with velocity Vd is known as mobility. Okay, mobility is the drift velocity of a charge carrier per unit electric field is called mobility. Mu, it is represented by mu, it is Vd by E. Velocity of charge carrier per unit electric field. This is the magnitude. Okay, magnitude. So from here, if I only write the magnitude, mu is equal to Vd is E by M and tau, and E is already there in the denominator. E and E will be cancelled. So mu, how much it came? E tau by M. This is one more formula. There are two formulas, Vd by E. Usually this will be used, but if you substitute Vd with E tau by M, you will get E tau by M as mobility. What is the SI unit? From here, if you see, this is meter per second. This is Q is equal to, this is Newton per Coulomb. Correct? Or in terms of voltage, if you want to write, this is volt. V is equal to E is equal to V by L. What is this? Volt per meter. Correct? From here, this meter will go up, meter square per volt second. That is the SI unit. Meter square per volt second. See here. Okay, this much is mobility. That's all. Only the formula is important and the SI unit. Okay, I hope you understood today's session. I hope you enjoyed today's session. In the next session, we'll be talking about current density and we'll be talking about Ohm's law. From where we have left here, Ohm's law where I told, from there we'll continue there. Okay, if you liked today's session, click on the like button. First of all, revise today's session again. Whatever story I told, frame it in your own words, each and everything, statement by statement. Okay, and revise the things. And yeah, if you like it, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. You can also visit our website www.v-learning.in. The live session what we are providing here, you will be getting lecture notes for each and every session there. You can download them and study. Alright, we'll meet up in the next session. Till then, keep learning from V-Learning. All the best.